So now that we've taken a look at what isotopes are, we're going to look at calculations associated with isotopes. And there's one calculation where we calculate for the average atomic mass of a particular element. Now this number accounts for all of the different isotopes of that element and also how abundant they are in nature. So when you take a look at your periodic table, what we consider to be the atomic mass is this number that we calculate, the average atomic mass, that takes into account all of the different isotopes of that element. Now, before we get into the calculation about that, I want to do one sample calculation with you about how to find your final mark in a particular course. And the reason why I want to do this with you is because this is exactly the same type of calculation that we are doing to find the average atomic mass. So say in an average course, you have term work. So this includes all of your assignments and quizzes and tests. That accounts for about 70% of your final mark. Then you've got your culminating, which accounts for about 10% of your final mark. And then you've got your exam, which accounts for about 20% of your final mark. Now, this tells you how much each assessment is weighted, right? So your term work weighs more than your exam and your culminating. And that means that it's going to have more of an impact on your final mark than the exam or the culminating. So say if you got an 85% on your term work, and then for your culminating and your exam, you got about 50%. Right? So what we would have to do in order to calculate for your final mark is to not only account for whether the mark that you got, so your 85%, your 50%, and your 50%, but also how much each of those assessments are worth. So this is the type of calculation that you would have to do. So you have to first take in the mark that you got for your term work, which is 85%, and I'm going to do 85 dividing by 100. So 85% times the weight of that particular assessment, which is 70. And I'm going to do the same for all of the different assessments that I have. So I got 50% on the culminating, so 50 divided by 100 times 10. And then again, for the exam, I've got 50% times 20. Now, if I do these calculations, if I do just this, I'm going to get 59.5 plus 5 plus 10. Now, if I add these all together, I will get 74.5. And this is my final mark. So see how not only does it take into account what mark you got, but it also takes into account how much each of those assessments is worth. And that's kind of like isotopes. So what we have to take into account is not only the mass of each of these isotopes, but also how abundant they are in nature. And that's usually expressed as a percentage. So this is why this calculation that we just did for your final mark is similar to the calculation that we are about to do to find out the average atomic mass. So here's a question where you are asked to find the average atomic mass of silver. And for silver, there are two naturally occurring isotopes. So I am given in this question the name of both of these isotopes. So I've got silver 107 and silver 109. I've got the mass of each of these and the abundance, or the percentage in which they are found in nature. So 51.8% of all of the silver that I find in nature is going to be silver 107, and 48.2% of all the silver that's found in nature is going to be silver 109. So there are two different masses. So in order to find the average atomic mass, we have to apply the formula that we just learned about. Now, this obviously, for the case of average atomic mass, is a little bit different. So instead of using the weightage of the assessment, we're looking at the mass of each of the isotopes. And the relative abundance is what we are taking into account as the percentage. So you are given the mass and the percentage for both of the isotopes in this particular element. Remember that the percentage that we have to divide by 100. What is required? We are asked to find the average atomic mass. And for our strategy, we're just going to use this particular formula, right? So the average atomic mass is equal to the atomic mass, that's given here, times the relative abundance plus the atomic mass of the second isotope times the abundance of that second isotope. So let's actually plug in the numbers to see what we get. So when I'm solving for the average atomic mass, let's take into account the first element here. The first isotope. And this first isotope has a relative abundance of 51.8%. So I'm going to do 51.8 divided by 100 times the mass that it has. So it is 106.9. And that's my first set. So I've accounted for that first isotope, silver 107. Now I have to do that for my second isotope the exact same way. So 48.2% times the mass of that second isotope, which is 108.9. So I have to find each of these calculations and then I have to add them up together. So if I do this, I'm going to get 55.3742 plus 52.489. And when I add both of these numbers together, I will get 108. And the units for this is atomic mass units. Okay, and that is it. This is how you would find the average atomic mass for any element given the information about the isotopes. Now in this example, we only had 2 isotopes, but if we had 3, you would just do the same thing, right? You would account for the abundance of that third isotope, and then you have to multiply it by the mass of that third isotope. Okay, that's it.